page 498. To be ready for this lesson, and it will be a long video because we're also going to do page 499 at the same time. What you need to know is you're going to have a protractor, rulers, tracing paper, pencils, because pencils work best with the tracing paper. You should probably even definitely tear out these pages for the stuff that we're going to do on them. So I've got page 499 also out, ready to go. So before we get started, let me go back and acknowledge something that happened in the previous video, and I said it, but then I didn't follow through with it. Remember, when you have an answer of x squared equals 42, that should remind you, or you should catch the red flag warning, the answer to that equation has to be both acknowledging a positive and a negative answer, because if you use the positive and replace x back in the formula, you will get a correct answer, but you could also replace the x there and the x there with a minus 6.4807 and get the same result. So I forgot to put that there, page 497. Go back and add the plus minus if you haven't yet. Thank you for checking on that. If that was like, didn't he just say that? I didn't see him do that. You are right. If you didn't notice that, come on, dude. Person, you need to be able to do better at noticing when something doesn't quite like mathematically smell right and to call it out. You need a bridge to cross over a canyon. The dotted line segment connects points S and R that represent the bridge. The distance between point P to point S is 45 yards. You can measure that. Because that's a number, here's something you should be doing with any of these types of problems. You're underlining or highlighting mathematical words, geometric representations, and specifically numbers. But then you have to go put those numbers on the diagram. The distance from point P, now I'm here. Point Q to point S is 130 feet. So point Q to point S, so that's this distance is 130 feet. Oh, snappers. So yards, there are 3 feet in 1 yard, which means that 45 is not big enough to be compared to that 130 feet. So I'm going to pop in an FT right here, and then I'm going to go times 3 to now bring my number up to the proper value. Hey Siri, what's 45 times 3? Hey Siri, what's 45 times 3? I think it's 135.
The answer is 135.
Okay, so this is actually 45 yards, 135 feet. To determine the length of the bridge, how long must the bridge be? That's another part of this whole thing. This is the question of this entire problem that we're going to answer in our Getting Started section. To determine the length of the bridge, you must first explore what happens when you draw an altitude to the hypotenuse of a right triangle. Hey Siri, what's an altitude of a triangle?
Here's what I found from cutthenot.org in a triangle. An altitude is a segment of the line through a vertex perpendicular to the opposite side.
So it's a segment of the line through a vertex perpendicular to the opposite side. So this QS is the altitude. I'm going to write that down here. QS. That's the altitude. Hey Siri, what's a hypotenuse of a triangle?
Here's what I found from Wikipedia in geometry. A hypotenuse is the longest side of a right-angled triangle, the side opposite the right angle.
Okay, so if this angle Q is the right angle, then PR is the hypotenuse. So I'm even going into the problem, and come on, when you say you don't know how to do something, don't just directly ask me, go search it up. And if you have a phone on you and you have, AI assisted tech on you, ask it and then learn from it. Be smarter than the AI. Let's investigate this relationship, and then you can answer the question posed about the length of the bridge. Which, by the way, right now, this is the length of the bridge from S to R, and we don't know how long it is, X. But what we are going to be able to figure out is, based upon the relationships of the sides and lengths of, there's actually 1, 2, and then 3 triangles in this shape, we'll be able to solve for X. When you draw an altitude to the hypotenuse of a right triangle, it forms 2 smaller triangles. All 3 triangles have a special relationship. I'm going to reveal it right now. I don't want to hide this phrase. It's relying on the property of geometric mean. Construct an altitude to the hypotenuse in right triangle ABC, and then label the altitude CD. There's a special technique to doing this. It involves creating a perpendicular bisector to a line segment from a point. I guess bisector is the wrong word. Creating a perpendicular line from a point not on the line. And the best way to do that is to acknowledge point C right here. See if I can slide this, center this, and zoom this in. Okay, point C right here is the point not on the hypotenuse AB. And if you take, this is where the tracing paper is semi-accurate, a little better to use than the compass and ruler construction that I would show you. I'm going to fold this over. Now, this is two things I got to do, right? Remember these two things and then watch how I practice them. I'm going to keep the opposite side overlapping. But I'm going to make sure it's also almost visible right here. I'm going to keep this dot on the crease of the fold. And I got to be very careful to do both of those. Fold this section on top of this section and keep the crease of my tracing paper as I fold it on that point. That way, the line segment that goes across here will be the perpendicular line. It'll be the altitude. I think I realize now why we even bother telling you about orthocenters. It's so that eventually when we have this conversation with geometric mean, there's a way to have altitudes ready to go. I did it. I creased it. I could probably do a little bit better of a crease by like just a slight adjustment, but I've got folded on the line, folded at the point, nice and sharp crease. I might as well pencil it in. There we go. That should be a right angle because of the way that we created it. I folded this line to overlap on itself, and the only way you can fold a line so it overlaps on itself is if you fold it along right angles. Now, name all of the right triangles in the figure. So I'm going to reference this. No, I need to do this. I'm going to flip the paper over. I'm going to trace in pencil on the back, and then I'm going to push this back onto the getting started paper. So fold, trace, trace, trace. This is why we have the protractor. This is why we have the tracing paper. By putting graphite on the other side, it's like pushing a shadow back onto the original paper. So when I fold this back around, now both sides of the tracing paper have pencil mark on them. Okay, now I'm going to trace it again. And I could trace it back on the original triangle copy, which would work, but I think this is probably fine for now. When I move the tracing paper away, enough of it's left that I can then come back with a straight edge, and I can trace the straight edge. Yeah, along the way. Going off Camry, here we go. Making the perpendicular line, and then I need the labels. I need this line specifically. Okay, so there's C, B, A, and then they said construct an altitude label, the altitude C, D. Okay, so there's actually, like I mentioned before, 3 triangles. There's the small triangle, which I'm going to use right now. Name them. I'm just going to name them, and then I think I'm going to draw them on the next page. So there's triangle A, D, C. I'm going to do something specific. I'm going to put the right angle as the middle letter always. Then there's the other side, B, D, C. I'm going to continue to do something specific. I'm going to put the first 2 letters that make up the shortest section of that triangle. So I'm going to put C first, then D, and then B, because this line segment is actually longer than this one. Okay. Then last of all, the big triangle, all the way big, and there was meant to be a right angle in that corner. Small section goes first, so A, C, B. Now the order of the letters might not look like it matters, but I'm trying to be consistent because it actually does. And the better you can spot the position of the letters creating similar triangles, the easier the rest of this math will be, because that's the first major hurdle. Okay, here we go. Question 3. Trace each of the triangles on separate pieces of patty paper and label all the vertices on each triangle. Arrange the triangles so that the triangles have the same orientation. The hypotenuse, the shortest. Oh my gosh, this is like crucial. And I'm not even showing you. It's so crucial. Let me zoom out a little bit. Zoom out, zoom out. Come on now. Move that up. Move that over. This is crucial information, so I want to make sure that it's visible here in the video. Arrange the triangles so that all the triangles have the same orientation. That means the hypotenuse, the shortest leg, and the longest leg should all be positioned in the same way. So it says trace them all. I already have it traced on the tracing paper on both sides, but I'm going to try to keep the letters, like I said, the letters over here were lined up. So all short legs, I'm going to draw the small triangle first. I'm going to draw the small triangle by positioning A, D, and C, and then draw it. And now I can take the tracing paper. I'm going to label my letters. A, D, C. And I'm going to go back and make them bolder here in a second. Now I have my medium triangle. And my medium triangle, pushing it over just a little bit, the short leg of the medium triangle, the long leg of the medium triangle, and the hypotenuse of the medium triangle. And because of the way I thought about the letters intentionally, C, D, B. And now last of all, the big triangle. And the big triangle is actually going to require a flip of the paper. So I'm going to trace on the other side. And it's going to go, I think it's A, C, B, which that's how I ordered it over there. Okay, there it is. I traced them, and I put the trace A, C, B. Do you have 3 highlighters? It'd be a good idea now to have 3 highlighters. In fact, I might have to go off camera so I can get them. I have a yellow, a green, and I'm going to get like an orange or something. Okay. Make all sides longer, or like darker, like make them be bold. When you trace the trace, go back over it. And I'm using a ruler because, come on now, don't freehand. Hold yourself to a higher standard. Make all your lines neat. Feel a little bit of pride and success in making your diagrams look good. It's one thing as a teacher I can easily tell who's taken care and concerned to do their work well. Now, short leg, short leg, short leg of the right triangle. Longer leg, longer leg, longer leg of the right triangle. Be right back. Where'd you go? Oh, I have it right here. Okay. And last of all, third color, hypotenuse, hypotenuse, hypotenuse. We also know the hypotenuses are, or hypoteni, I don't know what the plural is, across from the right angle. Okay, name each pair of triangles that are similar. Explain how you know that each pair of triangles are similar. And here's the deal. If I can create a fraction of yellow to yellow and green to green, they're going to be similar in this situation. I have angles in the middle, so I can say it this way. It's now take the letters from here and put them onto question 4. Triangle ADC is similar to triangle CDB is similar to triangle ACB. The reason for that, each pair of triangles that are similar, they're all similar to each other. And we know that they're all similar to each other by SAS similarity, or even side similarity. I have 3 highlight colors on the sides, or I have the angle, that's a right angle in between them. Now it says write the corresponding sides of each pair of triangles as proportions. So by choosing my letters in a specific arrangement, I can say AD, CD, and AC are all in the same arrangement. They are the yellow sides, the short legs of the triangle. So I can write AD equals CD equals AC. I'm putting them into the top of the fraction. Now on the bottom of the fraction could be the other color. So I'm going to pick DC, DB, and CB. Those are the long legs that I highlighted green. DC, DB, CB. Those are going to be the bottoms of the triangles. Here we go. DC, DB, CB. That's one arrangement where I'm going yellow to green. But I could also go yellow to orange, which is what I'm going to do in this video. So at this point, I'm going to recommend maybe you skip forward like a minute and you try to write down the yellow to orange proportions. And then write down the other one that's missing, the green to orange proportions. I'm going to do all of that right now. I have a third color so I can help facilitate that because these two are the hypotenuse sides, these two are the hypotenuse sides, and these two are the hypotenuse sides. So I'm going to put all those together. I'm going to do yellow to orange proportions, and I'm going to do green to orange proportions. By the way, hint, for like way in the future, hypotenuse lengths should go on the bottom. Oh, and by the way, skip forward a minute. Skip forward. But while you're skipping forward, I'm going to be writing down those proportions. You should practice the same. So that's what I'm going to do. You do that as well. Okay, yellow to orange. AD to AC. CD to CB, and AC to AB. And then last of all, this is yellow, yellow, yellow to orange, orange, orange. Last of all, DC to AC, DB to CB, CB to AB. Green, green, green. Orange, orange, orange. There are other ways to write these proportions. I love these because they are actually forward thinking for the future, for next topic, next module. However, when we see them, the key thing I want you to recognize is that this is every yellow compared with every green in the proper way. This is the yellow compared with orange, and this is the green compared with orange. But there are like 3 fractions because all 3 triangles are similar. And if we happen to know, like in the bridge, how long this side is, or if we know how long these sides are, whichever the arrangement is, we have formulas for where we would put them, which I'll show probably in another video or show it as a short. The point is, this is it. This is going to be specifically known as the right triangle altitude similarity theorem, which says if you draw an altitude from to the hypotenuse of a right triangle, then the 2 triangles formed are similar to the original triangle and to each other. Thank you for watching this video. This has been page 498 and 499. Next up is the activity on geometric mean, the big idea. So thanks for sticking around and watching this video, and I hope you are able to learn a lot from it. See you in the next video. Oh my gosh, 500. We are on page 500 next. Thanks for watching this episode. Like, comment, and subscribe. Bye.